Okay, now the section on modular arithmetic in the IB option, discrete mathematics. All right, so I'm going to put 5 videos together for each of the 5 separate areas covered by exercise 5A through to 5E, and we just start out by looking at what modular arithmetic is about. It's really just based on divisors and remainders. So what's left over when you divide a number by another number. So really we're working from a number n being equal to when divided by a divisor d, we have a certain number that it goes into that go into it plus a remainder. Okay, so if we just break up each of these pieces, the r is our remainder, our d is our divisor, k is any integer, and n is any number. So for example, we could say that 20, if we divided by, say, 6, would be equal to 3 times 6. So my k is 3, my divisor is 6, and my remainder is 2. So in modular arithmetic, we can write this. So therefore, we'd say that 20 would be equal to 2 in modulo 6. So when divided by 6, there is a remainder of 2. We're not so worried about this k. We're really interested in just what's left over after the division. So we could also say 14 is equal to 2 mod 6, and therefore that 20 and 14 are congruent in mod 20 is congruent to 14 in modulo 6, which is equal to 2. The remainder is the same. Okay, so if we have a look at now, we just start looking at some properties, I suppose. We'll have a look at the example on page 52, and on page 52, I'll just write that out. So if we start off with x equaling or being equivalent to 6 mod 12 and y is equivalent to 3 mod 12, then what would we say? What could we say about x plus y? Okay, well then x plus y, if there's 6 left over when you divide x by 12, and there's 3 left over when you divide y by 12, then what would the x plus y give us? Well, we could have a look at each of these in terms of what they are equal to as an equation. So if x is equal to some multiple of 12 plus 6 with a 6 remainder, and y is equal to some multiple of, so rather than use k, I'm going to use a and b here, I think, just for consistency later in the exercise. 12 by some other number b, some other integer b, plus 3. Then if we add them together, x plus y will equal, you can see we'll have 12a plus 12b plus 6 plus 3. So we'll have 12 lots of some integer a plus b plus 9. So you can see that x plus y is going to equal 9 mod 12. So we can just add the 6 and the 3, and that's what we get mod 12. So x plus y will equal 9 mod 12. Okay, and if we have a look at, well, in fact, if we said x plus y is equal to 9, what would x minus y be equal to? Would it be equal to 3? And we could use the same technique here. We could go across and we could say, if this is the case in red, then x minus y will equal 12a plus 6 minus 12b plus 3, which will equal 12a minus 12b plus 6 minus 3, which will equal 12a minus b's plus 3. So there's my remainder now, 3, and so my x minus y. So x minus y is equal to 3 and mod 12 because this is some multiple of 12. So we can go back over here and say x minus y is equal to 3 mod 12, and that is just 6 minus 3. So that's a nice little result. Now what would happen, let's have a look at, say, x times y. So what would happen with x, y? So then x plus y, and just to keep this story unraveling, and xy. What's xy? What would xy be equal to? Well, is it 6 times 318 mod 12? Let's check it out. So if we get over here, and here's my x and y, xy will equal, what's it going to be equal to? 12a plus 6 by 12b plus 3. Well, that's equal to 12 by 12, so that's 12, or I should say 12 by 12, 144ab, and now this is equal to 12 times 3, 36a, plus 6 times 12, 72b, all multiples of 12, plus 18. So we can write this as 12 lots of 12ab plus 3a plus 6b plus 18. So it's actually equal to 18 mod 12. So yes, the xy is equal to 18, or 6 times 3 mod 12. So that's all good. Now, what we need to caution ourselves here is we've looked at the 3 of the 4 operations. Is x divided by y equal to 2 mod 12? Is x divided by y equal to 2 mod 12? Is it? Right, big question mark. Is x over y equal to 2 mod 12? Well, not quite so straightforward for us to do an algebraic maneuver, but we can test on this using some values. So if x is 6 mod 12 and y is 3 mod 12, well then we can say that x is equal to it was x equal to 6 mod 12. So x is equal to 6, or it's equal to 18, or keep adding 12. These are all the values that x could be, and y is 3 mod 12, so it could be 3, or 15, or 27, or 39. These are all the values that y could be. These are all the equivalents of 3 mod 12 for y, and these are all the equivalents. So these are equal to 3 in modulo 12, and these are equal to 6 in modulo 12. So these are all our possible values. Now, if we do a division of 6 divided by 3, yes, we get 2, but if we do a division of 6 divided by 15, we don't get 2. Or if we do a division of 18 divided by 3, we get 6. If we do a division of 30 divided by 15, we get 2. So we get different values. So our message from this is that x on y is not necessarily equal to 2 as a remainder mod 12. So we're going to hold there, and we're going to establish some some addition, subtraction, multiplication rules here, but not division. We'll have a look at division and how it works in the next YouTube. But what I'd like you to do now is just have a look at exercise 5a on page 52, and if we just have a look at maybe the first example, if we have a look at question 1a, and what you could do now is you could pause the video and have a go at exercise 1a part 1, and in fact I'll do b part 1 as well, and then we'll come back and check on our answers. Okay, 1a part 1, if x gives a remainder of 5 when divided by 12, so x gives a remainder of 5 when divided by 12. That's what it means. Then 2x will give a remainder of 10 in modulo 12. Now in b part 1, if x gives a remainder of 5 when divided by 13, what remainder does 4x give? So 4x will give a remainder of 20. We looked at this. We can times our remainders, and sorry, we didn't look at this. This is just looking at if well, actually, maybe what we need to do then is have a look at if in this case, if x is 5 mod 12, that means that x is equal to 12 times some integer a plus 5, and then 2x will equal 24a plus 10. So we've got that's equal to 12 by 2a plus 10. So that's equal to 10 mod 12. And so you can see that's our result there. So we can, if we're taking multiplying one side, you can multiply the other. 4x is equivalent, or so then we get 20 here, mod 13. So using that same ruling, then 20 mod 13, well, that's equivalent to 7 in mod 13. So if x is 5 in mod 13, then 4x will be 20 or 7 in mod 13. Same logic as over here. If we're going to take this as x will be equal to 13 by some integer plus 5, then 4x is going to equal 52 by that integer plus 20, which is 4 by 13a plus 20, which is equal to 20 in, oh sorry, I did that the wrong way around. We're in mod 13 here, so that should have been written in 13 by 4a plus 20, so it's equal to 20 in mod 13. So in the next YouTube, we'll look at generalizing some of these results that we've established in this video. I'll see you soon.